Okay, so let's try these examples. I bought this pen and let's see if I can make it work here. So here we've got a couple of differential equations given with initial values and then given with the solution. So for the first one, the differential equation is y prime equals x squared, and our solution is at x cubed over 3 plus 5. Well, let's take the derivative of this. So if you take the derivative, oops, the 5 goes away, and down comes the 3. And so 3 divided by 3 is 1. And we take 1 from the power, and so we get x squared. Okay. And so the derivative of that is x squared. And if we plug 0 into this, we get 5. Similarly, if we take x to the 4th on 4 plus 5, we take the derivative of that. Again, 5 disappears, down comes the 4, and so we subtract 1 from the 4, and we end up with x cubed. And then if we plug in 0 in here, we get 5. And again, x to the 4th, y prime equals x to the 4th. So we try this one, we take the derivative of this, 5 disappears, the 5 comes down, so cancels out that 5, and we're left with x to the 4th. And so we see that this equation right here is a solution to that IVP. And so now we want to guess a general formula for the solution to y prime equals x to the n, y0 equals 5. So since we want the derivative to be x to the n, so maybe we should start with x to the n plus 1, right? Because when we take the derivative of that, we'll get x to the n, but down will come an n plus 1. So if we divide this by n plus 1, that's going to work. So the derivative of this is going to be x to the n. Now when we plug in 0, we're going to get 0. We want the answer to be 5, so we just add 5 right here. Okay, and that is indeed the answer. Okay, so let's try a little harder one. Y prime equals y squared, y naught equals 5. Okay, and I claim the answer is 1 divided by 1/5 minus x. So let's just first check that y of 0 works. So where is it? Y of 0 equals 1 divided by 1/5, and that is indeed 5. So that works. Next, we've got to show that the derivative of that is equal to y squared. Well, y squared we know is equal to 1 over 1 to the 5th minus x. That's all in brackets, and that's going to be squared. Okay, so we've got to show that that is the same as the derivative. So let's take the derivative of 1 over 1/5 minus x. So we're going to use the chain rule. So we'll let u equal 1/5 minus x, and then y is going to be 1 on u. So the derivative of this is going to be minus 1. That's the slope there. And the derivative of that is going to be minus 1 on u squared. Okay. The chain rule says we multiply those two things together. So we get the derivative is going to be 1 on u squared. So this y here, of course, is dy du, not dy dx. And 1 on u squared. And of course, u was 1/5 minus x. So we see indeed that y prime equals y squared is the solution to this equation. Okay, and one last problem. y prime equals 2.3 times y0 equals 5. And I claim the solution is 5 times 10 to the x. Well, what is the solution? Well, the derivative of 10 to the x is going to be 10 to the x. Oops. Times the constant for 10, which we know is 2.3, right? That is just the derivative of 10 to the x at 0. And then since it's multiplied by 5, we can multiply it by 5 right there. Okay, and you see that that indeed is 2.3 times yx, because yx is 5 times 10 to the x, so that's equal to 2.3y. So it does indeed satisfy that differential equation. And then the last thing it has to show is satisfy the initial value problem. Well, y of 0 equals 5 times 10 to the 0. 10 to the 0 is 1. So that means y0 equals 5. And so it satisfies the initial value problem. And that is indeed a solution. Thank you.